can hear me okay? I'm not going to keep the chat up during the talk. It's just,
yeah.
I have an attention span problem as it is.
Yes.
So I think generally we'll have QA at the end. Is that right?
Yeah, sure. Yeah.
Okay.
Anyway, thank you all for coming. Good morning. I'm Jim Katz, and since like September of last year, I transitioned from 30 years in software development to become the archival operations manager at the Buddhist Digital Resource Center. And it's been a big change because I went from just coding, and testing into more of a DevOps world where I had to both manage our network and our users, and also cope with a lot of success that we've had. Where is, here we go. Yeah, so a little bit about the BDRC. We're a digital online library, and we were founded around 2001 by Gene Smith, who was a Library of Congress employee who went over to India to acquire texts, Indian publications for the Library of Congress. And along the way, he fell in with the Tibetan community and acquired a large number of classical Buddhist religious texts, many different kinds of works, and brought them back with him to the States. And some friends of his at the Rubin Foundation persuaded him to develop an organization that would digitize them and put them online, and they busily started that around 2001. And sometime, I think around 2011 or 12, they finished the original collection and started working with other partners to scan and digitize their texts in the field. And largely what we've done is we've sent over personnel to go and set up these digitizing stations and train people in doing them, and then they would come back home and the people would just go and digitize, and we'd figure out how to get them back to the central headquarters later. Another kind of dimension in our change is that we're moving beyond Tibetan texts. A couple of years ago, we changed our name from the Tibetan Buddhist Resource Center to the overall Buddhist Digital Resource Center. And most of our acquisition is coming from non-Tibetan texts from like Cambodia and Thailand at this point. We're basically doing this by partnering with other institutions who are largely taking over the digitizing from us. So a little bit about this presentation is that this is kind of an interim report on an ongoing process that we have. We've been using AWS to serve our images to the cloud for a few years now. We used to do it locally, but you can't serve a worldwide resource through 100 megabit consumer internet connection, as we found out. So that's all moved off site, and that's not really part of this talk. I'm really talking about how we've acquired the files and how we're going to be moving them around. That's my bailiwick. Basically, our internal intake has just tripled. It looks like we're on track to store 60 terabytes of new data each year, 15,000 works, 4 million new images, and that's per year. So I want to say a little bit about our old approach and why it's not working anymore. But also, when we started this cloud project, we were like Tyler here. We were going to crush the web. We were going to make AWS like groan and bend under our huge workflow that was just going to like pump data instantly from Asia, into our servers and then to the web. And a couple of months in, we're actually kind of more like this right now, or at least that's sometimes the way I feel, because these dreams actually met reality, and the conflict was interesting, and we learned a lot more from than just having done it right to begin with. So back in the old days, when we had our own scanning staff, basically you would have a few people working on a workstation, and that workstation would dump stuff to an external hard disk drive that was, maybe a few terabytes or so. And then somebody would disconnect that drive and plug it into a Mac Pro and, polish up all of the images, and then take that drive and plug it into the server and transfer it over to the server's load. And it was all done on a batch basis. We used a lot of bash scripts to move the files around. And the basic presentation was, I've got a chunk of works. Here they are. I know where they are. Go into them and work on them and move them around. So it was a very manually oriented process. You would go in and just, as part of your workday, you just set up this process, and you'd have to go and go off and do something else while it was running. So the flow we've got today largely looks like this. We have materials and scanning that's coming in from Thailand, Cambodia, Mongolia, and China. The Chinese workflow is very special for hugely complex reasons I don't want to get into here. But the destinations are out to our web host to publish it, and into our file server farm to store them and back them up and essentially keep them safe. And the kind of physical aspect of this isn't like starting a job and then running it in the background until it's done. We're actually looking at multiple parallel streams that can take hours or days to go through. So we have a bit of a job management issue that has to be managed, because you need to know where to look for these jobs, where to look for the output, where to look for the loggings, how to signal issues. That's kind of our largest unanswered question right now. But a little bit about the volume. Each of these issues, each of these flows in the previous slide, can contain up to hundreds, or sometimes maybe about 1,100 works or so. Each work traditionally comprises, 1 to 20 volumes. Each volume is somewhere between 200 and 600 images. Mostly in recent times, we're just getting 1 volume per work, because that's the way they're organized. One image usually is represented in 3 separate files. There's like the master capture file, a cropped master, and then a web image, which is negligible in size. But all told, one image can run up to about 60 megabytes. So each work goes up to about 10 gigabytes. And if we do 4,000 works a year, that's actually like 40 terabytes of data that we're acquiring every year. And managing just storing that is one issue. But this is about flowing 40 terabytes through AWS, through multiple streams, and how to keep an eye on that. So when we first started to mock this up, our staff came up with this proposed workflow, which was to get some backlog from one point to another. Our boss, who's not a technical person, came in the next day and erased it, which actually, in retrospect, is probably really, really more helpful than trying to work from that, because it was trying to apply our old way of thinking about batches to something that didn't really apply anymore. Just too many entities, too much stuff, too many steps. And it was, it was really good that it got erased when it was still young. So that was our first cut of the problem. Our second cut was much more automatic, and this was a bit of a dream. And in here, the bits flow from lower left to upper right. And this boundary here on the left that's marked DDD stands for the digital divide data. And our hope was that they would upload a work into the cloud onto this bucket that they owned, and that they would send us a message through Amazon SNS. And then we would go and trigger off an AWS Lambda that would go and process this work, tell the BDRC on-prem server that it was done, and everything would flow, cloud, CloudWatch, everything. Just this is what AWS loves to tell you they can do. The idea was that we would fully process each work as soon as it was ready. Ha! Ha! Well, when we thought about that, we kind of lost track of the fact that our partner was not obligated to do that. The DDD contract just said, we will deliver these works by a certain date, which meant that they delivered all 1,100 works on that date. That was their target. We can't change that. We wouldn't want them to change their flow. As well, a lot of our other partners also had huge backlogs of the master files that we needed to process and get into our system. We had already sliced out the web part and published that, so that was not a problem. But we needed to get a lot of those backlogs. So this is all really about processing the backlog. And the other main problem with a Lambda was really that they're evanescent, they're meant to be transient. They have a maximum lifetime of 2.5 minutes. And when Amazon loves to talk about how they're how great they can do, they give an image processing and rendering as an instance. Well, that's one image. We have like 500 per work. Each Lambda instance to process one image would cost somewhere between like 25 and 50 cents. So that's like 75 bucks just to process one work, let alone 1,100 works. So the other issue is that we can't do much in 2.5 minutes. When we process a work, we need to make sure that we're processing every image in the work, and you can't distribute 150 tasks out across a bunch of Lambdas and have a prayer that they're all going to report success or failure reliably. There's just no reason to do that. So what we did, we've come up with a bit of a hybrid architecture that uses EC2 for some work, on-premises work for some of the other work. So the first issue is like, how do we acquire all of these texts from our partners? And we found that we use a set of file servers that are made by Signology. And we really like Signology as a partner because they offer out of the box a boatload of really useful applications that are meant to, they're meant to be tailored from a file server. So if you need to do something like an rsync, you can set up that service through the Signology's UI, which is a good idea because the Signology, their tools will automatically take care of throttling for you. You don't have to worry about swamping the file server's bandwidth. It'll just take care of it. And it does it very nicely, although slowly. So they have a lovely little service that allows you to just like point a number of files and directories at an S3 cloud server and just say, here, go and do it. Oh, and by the way, do it during off hours. Because the two issues that we have in getting from this Signology DSM and back onto ours are the actual bandwidth from the site. Many of these partner sites are nonprofits or libraries or small institutions that don't have very much bandwidth, and we're sharing our station with other users at that site. This is particularly true in like the National Library of Mongolia. There are other issues that you just don't find in the States, like say in Mongolia, they want to save money on electricity. They power down the whole building. And the staff on there is good about making sure that equipment is shut off. But if you think about it, that in our Western-centric world, we never turn off anything. We never turn off computers because we want them on all the time. Maybe that comes from a deep-seated superstition that if you shut it down, it won't start again. But this is just kind of a field assumption that you have to always take into account. So we're using Signology Cloud Sync both to get the data up to our partners bucket, which is in Asia. So we don't have a big cross-world hop from their premises. And then we can set up manual or automatic cross-region replication, a nice service of AWS, that just says, oh, mirror this drive on my incoming drive. And then we can apply the same process in reverse to trickle down that partner's cloud down to our own file server. Again, at our site, we have very limited bandwidth. People are sharing it, especially for Zoom calls, for Google Drive, which is Google, basically we're a Google Drive shop, surfing and other, transfer processes that we've got going on. So it has to play well with all of those other users. We're moving a lot of this local stuff to a dedicated co-location facility soon. So that bandwidth might be removed, but it's still something that we always have to take a look at, is who else is using this network, because we're not massive corporations. So what we also can do, or we're trying to do now, is to move some of this processing onto Amazon EC2, Elastic Cloud 2, just regular virtual CPU instances. These little socket grids here that say T2 are kind of Amazon speak for a very small system. So up above, we have all of our partners' S3 buckets syncing nicely, or either manually or automatically, to our incoming destinations. What the lower part of this grid represents is kind of a 4-part process that we would just launch an EC2 instance from our console here and start processes on it manually. The first one we can do is we can frog march any specific data that we want through AWS S3 Sync and just get that onto our incoming partners bucket. Then we can use that same facility to move it from the S3 object store onto an Amazon cloud disk. And the reason you want to do this is because we've developed a lot of our software basically has to be on a file system. And trying to rewrite all of that to deal with objects in an object store is just pointless, hard, difficult, and failure prone. We have some modules that do that, and they're just so much more involved than just like using a Python directory iterator to iterate over the contents of a directory. So it's better to just like suck up the cost of doing this than to like pay programmers a lot of money to rewrite the code to do that. So that's step 2, is we do this sync. Step 3 is we would also we would then run whatever processes we need, which has a read-write relationship with this NFS mount, because some of our processes create artifacts that we want in the partner flow. You sync the results, use again this same really useful tool to sync the results back to the original host, so that whatever process in step 2 or 3 added go back to the host. And then we would go back to the that S3 sync that we saw on the previous slide and have that incoming partners file just replicated to back to our system. So far all of this works, but we still haven't really gotten over the I have to come in and start these processes and batch them up issues. So we're still looking at that. But along the way, I mean, giving this talk is a good chance for to just reassess what we've learned about this, and what if I had to rewind and do this again, how I would do it. And the first thing I do is basically get more input, get other people more involved in storyboarding and use cases, determining what the performance metrics are. The real problem, I wouldn't call it a problem, but a feature of this whole architecture is that there's one user, me, and I'm also the developer on it too. So I have to tell myself what I want, and then I have to make sure it's what I want. And that's a little bit of a closed loop. So opening that up and having a more formal kind of development process is probably where we're going for this. Another issue is bumping into just the geography of how Amazon Web Services work. Their underlying assumption seems to be that you work for a mega corporation and you have lots of resources and you have a real firm development and DevOps infrastructure that can manage all of the artifacts that you create. Just as an example, I created, they have a process called CloudFormation that you can use to drag and drop some items onto a template, or to start with a template. So I was designing this template that I showed you in the hopes and dreams slide way back when. And just that template alone created like 17 entities. It had users, it had policies, it had queues, it had subscriptions. Each queue got a separate user and a policy and a key. And it was just like, all right, that's the most complex. It started out with the most complex solution to the problem, or the most general solution, to be fair. And thinking, all right, I don't know much about AWS. How do I cut this back to what I actually need? So, so working with templates and samples can give you something that's very scalable. But if you're beginning at it, you really need to think carefully about whether it's worthwhile building that out, or just taking the idea and building the least minimal thing that you need. I mean, it takes 5 minutes to create a simple notification queue, and another 3 minutes to create and test a mail subscription, so that you can do, just send mail when you send an Amazon notification. And from there, you have a very simple command line tool that you can embed into a script or a Python script that'll send mail when you have an event. It's not complicated. It doesn't use specialized roles or anything. It's probably not safe, but it's what we're doing now. The other issue that we always have to be aware of is not to overbuild, because we're a small nonprofit. We have a technical staff of 2 or 3 people. Everyone has multiple levels of attention that they need to do, and we don't have people to monitor this process full time. We also realize that should anything happen to me, I'm fine, thank you, that we don't know. We don't know if the system is even operable by somebody else. So there's always that risk of somebody situation changing. One of the things I found out that's actually more helpful, despite all my whining, is that Amazon Web Services is widely understood. It's documented. Somebody on Stack Overflow has already found and answered a problem that's a lot like anything that I've run into. And so if they can't answer it directly, they at least point you to the areas that you might investigate to actually solve it. They might also point out how you're actually like creating this problem because you're doing something that really doesn't fit the situation that you're trying to accomplish. So the next steps that we have to do, that's interesting. There we go. The next steps are really to get the AWS into some kind of code configuration, because it's very easy to do a lot of things through a web UI, and that all results in little JSON snippets that are artifacts. But essentially what the UI is doing is emitting AWS commands that you can do through the command line or through a script that replicate that. So if we wanted to recreate this Amazon environment, we would have a mess of scripts, permissions, and little data artifacts. We don't have a way of managing that right now anywhere in our code base. The website team has it in spades because they just have many more entities that they have to manage. So I don't know how they're doing it. The second issue is to do logging and messaging, monitoring these long flowing, slow workflows that take place over time, and only filtering out. We don't need to know that 99,000 files, went correctly. Just that that one of them failed. So we're going to be looking at bringing in messaging into some of those processes. And actually, we're starting to use it even on our own internal processes, because it is the best way of sending up a flare when one of our background services has gone wrong. So Anyway, before I take questions, I just want to thank a few people that made this possible. Jan Ronis, our executive director, who kind of supported me in doing this talk, our archival operations staff, Travis Detour, who has basically traveled the world, set up many of these stations, and discovered that manhole covers in Mongolia are not always as reliable as they appear to be. Tim Buckingham, who's newer and just started to crop this. From Harvard University, Richard Lesage and Vitaly Zakuda, who have graciously accepted to take our holdings and save them for posterity. And a lot of the software behind this is inspired by Jake Johnson from the Internet Archive and his boss, Brewster Kale, who frog marched me to a PC one night and said, I can get you to upload a work into Internet Archive in 5 minutes. And by God, he did. So those are all the people I'd like to thank. So that's it. And I'm ready to go to the chat and take questions. So here we are.
Thank you, Jim. Would it be helpful if I read the questions out of the chat, or people can actually open up their mics and
let me see. I'm looking at the chat now. Would a tool like Terraform be appropriate here? Gee, is there any way we can open up the mic to Gavin to tell me a little bit more about Terraform? Would that be possible?
Yeah, sure, absolutely. This is Gavin. You actually have multiple tools in this arena. Terraform is probably the most mature in the sense that it tries to be agnostic. It cut its teeth on Amazon, but it's now sort of going into DigitalOcean, Azure, others. But essentially, this would be the tooling to manage your AWS configuration.
Yay. Thank you.
There's
Thank
also,
you.
There's also AWS CloudFormation. I think it's CloudFormation. And that is the AWS specific, but the talk around the campfire is essentially, so far, Terraform came out first. It's much more mature, and it doesn't have vendor lock-in.
Yeah, thanks. That's definitely worth noting. I use CloudFormation, and I think my problem with it is that they, as I said, I started with a template, and it just got out of hand really fast.
Yeah.
And you have to know a lot about what you absolutely need versus what they're suggesting as a template. And I don't have that level of experience yet. You've just heard in 15 minutes my total experience with AWS. So
what you were talking about is to use a template that they already have in AWS to modify. Yeah, those tend to be very, very general.
Yeah, they're over generalized. Yeah.
CloudFormation is a lot more cumbersome to write than Terraform, although Terraform has its quirks, so it's not a but it's a lot better.
And the idea behind being able to persist a Terraform, project or resource in one place, if that's what it can do, sounds really attractive.
Yep, you check it into Git repos for sure.
You bet. Yeah, except for the passwords, eh?
Well, those two. Yeah, those two.
The hell.
In fact, I gave a talk about Terraform yesterday, so if you're interested in contacting me directly, I can guide you around, and there's a repository with some.
Thank you. I wish.
So this is Alberto Castro.
Yeah. Wow, I will go back and read that.
No, I would love to talk to you. It would be, fun.
Also, on the logging and messaging front, considering the complexity and what sounded like very much like a queuing nature, I would actually look at Amazon MQ in conjunction with either, well, there's a variety of buzzwords here. So I'm not necessarily saying, hey, use all these things. I'm just saying potentially consider reviewing SNS, CloudTrail, SQS, and Amazon MQ.
Well, I can answer each of those, and I've looked at some of them in greater detail than others. SNS and SQS. SQS is very powerful when you're actually working in a workflow. And we took a look, and I'm still investigating Amazon's workflow modeling offering. I don't have the name of it right off the top of my head, but it's got promise for you run this as a workflow. It'll spin up the EC2 instance. It'll tell it what jobs to do. It has multiple parallel gates. It looks very tempting. The only issue with it is that right now we don't manage our input that way. Although I could, in theory, write something that just iterates over each of, say, our partners' S3 source buckets and launches this workflow on them. I've still got some development to do that, but their workflow, it's just called Flow Engine, is really tempting. CloudTrail, if I can get reporting on just errors to CloudTrail, I'd be happy with that. Right now, I'm just using SNS because it just launches really fast. It's really lightweight, and it does the bare minimum that I need. MQ also, we don't have, our architecture isn't queuing. It's not event-based right now, so it's not really the right tool for that at this moment.
The CloudTrail is really to log all the events that happen in the infrastructure. So somebody created a bucket or things like that. So it's it's a different thing. It's more for auditing. CloudWatch is the one that you might want to consider because you can publish events there, although it tends to be complicated to use sometimes. But
I found that out. I mean, part of it is that I've actually got to get even the unstructured version of this going. So once this runs, CloudWatch, once this gets running, I can replace pieces of it with better pieces, even probably in flight if I can. So if I can just run a quarter of my workload, and then while that's running, I'll develop CloudWatch. I can throw in the next 3/4 of the workload. So as I said, this is definitely this is an interim report. Maybe I'll come back next year and talk about how we finished these next two things.
Please do.
Yeah.
Jim, do you want to paste your contact information into the chat for participants here? They want to follow
sure.
you. That would be really cool. I also, in the chat, I posted a link, the Nerd Summit 2020, because it's all virtual. It's all being uploaded to YouTube as well. So we have Alberto's talk. I pasted that link.
Yeah. Oh, thank you, Noah. Yeah. So, gee, I thought it was going to be long, but turned out.
Give us time to discuss. Actually, I still have some questions about
go ahead.
Details. I mean, you somehow these EC2 instances that you're running. So what is exactly the process? So what? Let me just tell you what I thought I understood. So you're copying the files into EBS volume, I imagine, right? Or just calling an NFS.
Yeah.
And that EBS volume you use to process the file because you don't want to rewrite everything, obviously. So this, are you using small instances, right? So you're using T2 instances.
Time is not an option.
But sometimes, sometimes actually this is something you may want to look into. Sometimes, even though they're cheap, they do things slowly. So sometimes a test with bigger instances. Sometimes having a bigger instance may actually get you better results in terms of money. You may do things a lot quicker, like 10 times quicker while paying 5 times more.
Well, so, actually,
so look into that.
That's where something, that's why I gave a shout out to Jake Johnson, because he introduced me to Parallel, which is just like the coolest thing since sliced toast. That way, we can scale up to an instance and say, here are your 12 processors, get going, which is what we do. We have some servers at home and we just get, we saturate them. You saturate the memory, the CPU, and the network right to the point where it chokes. And And we could do that, with a more expensive instance. We just have to make sure that, and this gets back to the automated nature. My initial cut at this step 2 would start an instance from a template that was preloaded and then terminate the instance. It would actually terminate itself from an AWS command because we didn't want to leave it running. That proved to be really hard to maintain because every time you want to change a component, you had to like rebuild the template, and so I abandoned that and just figured I'll just start and stop an EC2 instance. Now, if I had better signaling of my client, I could, send a controller back at my local thing, a message that would shut down the system. There's lots of ways of doing it, and it comes back to messaging and logging. So as I get expertise in that, I'll be better able to control like this T5 instance, and just have it blast away and then turn off.
Right.
Yeah.
Other possibilities are using, I know you don't have an event-driven pipeline yet, but you may would like to start looking at the CloudWatch events, because those may trigger things. Like if there's something that appears in a bucket, then you can trigger something that happens. So that's actually the paradigm of.
Oh, that's right. Yeah. You drive it to an SNS or to an SQS.
Well, whatever. Yeah. I mean, you can do innumerable things. So that's one possibility. But in an experiment, try different things. I mean, the difficulty is always the main solutions. The problem is what's the right solution for you.
Yeah.
So you have to do a lot of experimentation to get the right one.
Yeah. And this is something I found out a lot in my experience there, is that I have to do something new, and that new object has to work on 2 different kinds of workloads. One of them is continually incoming stuff, because we're not standing still, and the other one is our backlog. Right now, this is geared towards backlog processing, but as we catch up with that, and I might just say, this is going to be the backlog process. It's always going to be automated. For new work, I'll start working on an event-based thing, because I can just really, I mean, this is, as I'm saying it out loud, sounds like a viable approach of just like developing one pattern for the backlog and another one for incoming things that can really exploit event-based systems.
Yep.
And then eventually I can just turn the backlog just to generate synthetic events to represent the backlog once I've got the event-driven done. But I need to get these backlogs out of here. They can't wait for the perfect event-driven solution. I need the truck first.
Yeah, no, of course.
Yeah.
The other question that I have is, where's the metadata for all this? Because you're processing stuff, but of course you need to find it. So where's all that information? How do you store that? Do you have a database? Or what?
When you say metadata, you mean for like example, the actual?
Yeah. So what I mean is, I want to know all the volumes that came from Mongolia. I want to know what in this one, what are the works, what are the
we just use buckets. We just use bucket names. There aren't that many partners. There's only 3 or 4 at a time, and these are year-long jobs, or multi-year jobs. They don't partnerships. We don't have that many of them that we need to lose them. So, just like on this slide, it's incoming.partner.1, incoming.Mongolia, incoming.NLM, and that's just what they are. But
for all this.
It would be nice. And one of the things, one of my hopes for actually, if that maybe next year this will be live, is being able to partner with people to write some of the little bits of code that we need on kind of a contract or an intern basis, to do some of those little things like scan and measure our queues, do metrics on what our backlog is, because there's a lot of things where we just don't even have metrics beyond counting files that finds of knowing where we are, and we don't have established workflows or measurements that measure the processes of these. We'd like to have them. Our board has asked for them, but the kind of pressure of daily work has always proved like it's always sunk down to the lower, it's it's always getting starved, and it's never quite where we'd like it to be. So we just don't kind of have the staff, but hopefully if we can start to develop, because we're a nonprofit, we depend on fundraising. And only recently are we starting to think about fundraising to support our technical infrastructure. Mostly we fundraise to do specific preservation projects or our overhead, but we'd like to get together like kind of a technology endowment so that we can do things like, spot work on a contract basis to build some of this up.
Thank you.
Yeah.
Really interesting.
Thank you, Alberto. Yeah. Yeah.
Yeah, thank you, Jim. I did post in the chat a link to the feedback form for Nerd Summit 2020. It's really helpful for us to get feedback so we can figure out how to improve for next year. There's no other conference for this room until, I think, until 2 o'clock, 2:15. I'll just leave this open. People are welcome to hang out here.
Okay, I'll sign off on my desktop, but I'm wondering how to, there's a little button here that says save chat, but it doesn't, I'm not seeing any dialogue as to where to save it. Do you know how that goes?
I don't know too much about that.
Oh, copy and paste. Great, okay, thank you. Oh, Noah, do you know, are there instructions in where I can send you a link to the slide?
Why don't you go ahead and send it to me, and I will forward it up to Rick Hood.
Okay, it's a Google thing. I'll try and send it as an object rather than something I have to give you permissions for.
Oh, I see.
Is that a problem? Can you post like a Google presentation? I'll try and find a way.
Yeah.
I'll find a way to send it to you. From Noah, do I have your contact info? I do not.
All right, let me put it here.
Yeah.
There we go. I put it in the chat there.
Okay. Noah, okay. All right, so I got those.
The recording will be going up to YouTube. I don't know how that happens. There's just magic that happens and it ends up there.
AWS. All right. I'm going to create. I don't want to create a board. Okay. I just need to copy this really quickly. Hello, Emacs. Okay, great.
Thanks.
Thank you. I'll head out now. Thank you, Noah.
Thank you. I really liked your logo, by the way. Beautiful symbol on the top of your slide. So it's wonderful.
Yeah. It's the best. That's a variation of the traditional Tibetan knot of eternity that you'll see in a lot of traditional graphics.
Thanks again, Jim. Have a good day.
Okay. Thank you. Bye-bye.